Oh, I almost forgot. Oh yeah, I just wanted to show you that another way another learner would have shown it, would have found the value of m, basically was to say that since they know that their c is positive 4, and then they had a graph, right, the parabola graph, and then it had its coordinates here, negative 2, and also had 2 and 0 here. Then it passed through there like that, and then oh, excuse me for my graph if it's funny, but yeah, then 0 and 4 here, right? Okay, so another way you could have done it was to say that we know that mx plus c, right, is a straight line, right? And because this is a straight line, oh yeah, and also the guys, don't forget that f of x is the same as saying y. This is the same as saying y, right? And now we do know that for us to find the value of m, we have to find a point, basically a coordinate that lies in the straight line, nothing else. You can't use the coordinate of b because b lies in the parabola. So this one we excluded because this lies in the parabola. We have to sub in a point that lies in within the graph of f of x. And here there was a point of intersection. Excuse me for my graph, but yeah, there was a point of intersection. You can just check the better page, you'll see. So then they will just say that, okay, I know that a lies in the graph of f, so therefore I'm gonna say sub the coordinates negative 2 and 0 into f of x, right? Basically that's what they would say. Then they'll be like, okay, I know that the coordinate, basically a coordinate is in the form of what now? It's in the form of x is to y. So we know that the coordinate is in the form of x is to y. So where I see, so basically I have f of x is equals to mx plus what now? Plus c. And then this was negative 2 and 0. So where I see x, I'm going to put negative 2. Where I see y, I'm going to put what now? 0. So this is going to be the new equation that's going to exist. It's going to be like this now. We're going to say, okay, we know that f of x is the same as saying what now? Y. So therefore, we're going to have 0 is equals to what now? M. M into what now? Negative 2 plus 4. Because we already know what c. C was 4, the y-intercept. Then they'll be like, okay, 0 is equals to negative 2m plus 4. Then you know the algebra comes in here. Then you transpose the 2m here. So this becomes 2m is equals to 4, right? And then you're going to divide both sides by 2, right? So this is going to be, it's going to be, so it's going to be, you divide both sides by 2. Therefore, you're going to see that, therefore, m is equals to what now? 2. So that's another way you could have approached it. And then you can just write down your equation. F of x is equals to 2x plus 4. And then any way is acceptable. Honestly, the teacher will accept this way and also the other way, how you would have done it. But just remember, if you want to use this way, only sub in a point that lies within the graph of f. Don't use any other point like b. B lies in the parabola, so we cannot use the parabola point. Thank you very much. Just wanted to expand one's knowledge, Yeah, just to tell you that, yeah, you're in the right track. So moving on to the next question. So the next question basically says that okay, how should, so it's 5.4 now. So how should G be transformed so that the new graph will have a y-intercept of negative 2 and still have a maximum turning point? So let me remind you guys of something there. When they speak of maximum and turning point and minimum turning point, they basically want to show you that. So it's basically this, right? So in the parabola, we have a sketch, right? That's like this, right? Let me just draw a rough sketch of it. So I'll just do this, right? This is 5.4. I'll just draw a rough sketch of it so I can show you something. Okay, so we have the parabola graph. So we know that when our graph is like this, right? The graph is said a is less than 0. We say that it is negative, right? The value of a is negative, it's less than 0. And when a is less than 0, there's going to be a point. The turning point of it is called the maximum point. This point here, this point here, where the graph turns, here it's going to be our max. This is our max. And the only time we have a max is when a is only less than 0. That's the only time we have a maximum point where the graph turns. So remember the coordinates of here was c, right, which was 0 and 4, right? And then 4, at 4 is where the graph tends in the y-axis, right? At 4 is where the graph tends in the y-axis, right? And then we also have a point minimum. So a point minimum is basically the opposite. So if your graph is basically sad, you're going to have a graph that's smiling, right? You're going to have a graph that's smiling. So basically your graph is going to look like this. And this only will exist right now. It will exist when your a is basically greater than 0. So when your a is greater than 0, you're going to have a point minimum. A point minimum. When a is greater than 0, you're going to have a point minimum. So now the question is asking us now the question is asking us here that how should G be transformed so that the new graph, so we're going to look into the graph of G. We know that this is the graph of G, right? We're going to look into the graph of G. We're not focusing on anything else, only the graph of G of X. So how should the graph of G be transformed so that the new graph will have a y-intercept of -2 and still have a maximum point, and still have a point where even if it moves down, it's still going to cut the y-axis and still will obtain a maximum point. So that's what they're asking you there. So now what do we do now to reduce? So we have to reduce our equation, right? So we know that G of X, right, is equal to negative x squared plus 4. Or let me write it in a different page, nah, such that it obtains a -2, right? Okay, so I'm just going to write it here, nah. Excuse me, I'm just going to write it here. So we know that it was G of X, sorry. So we know that it was G of X. So we say G of X is equal to basically negative x squared, right? Negative x squared plus 4. Okay, and then it needs to obtain a y-intercept of -2. So guys, oh yeah, and by the way guys, when we're dealing with functions, there's what we call a vertical shift. So a vertical shift is basically the up and down shift. So it just tells us that how do we move our graph, because then the graph will shift either up or down. So in this case, we're dropping our graph to -2, so it has to move down. How many units down though? So we know that this here, let me just remind you guys that G of X is, so let me just let me even rewrite the equation of a parabola graph. Ax squared plus q, I think it was like, yeah, ax squared plus q. So q stands for the vertical shift. This is the vertical shift, and then a just tells you the shape of your graph. Shape of graph, whether your graph was sad or smiling, a tells you that, right? So that's basically what a tells you, and then q just tells you your vertical shift. So now that means that the graph must shift 2 units down. How many units down now? So from 4 to -2, we have to move our graph how many steps, guys? So let's see. I think we have to move 6 steps down, because then we would obtain a negative, right? If I'm not mistaken. So we know that f of x must be equal to negative x squared plus 4 minus 6. Plus 4 minus 6. Yeah. To obtain a y-intercept of -2. So f of x will be equal to negative x squared. 4 minus 6 is -2. So that's fine. And then, so we're just going to say so that, therefore, the graph of G, right? The graph of G should basically move 6 units down, right? 6 units down. Yeah, it should move 6 units down. I can even draw a rough sketch of it. So let's draw a rough sketch. So the rough sketch would be like, I'll just draw a rough sketch of it. So it had a y-intercept of 4, right? So this was 0 and 4, and then it moved 6 units down, right, towards -2. So let's say -2 was around here, you know. So like your graph would like exist something like this, because then it would drop towards -2, and then it will exist here. It will exist here, and then it will still obtain its maximum point. But however, it's gonna be below the what's this, the x-axis. Oh no, why am I? It's going to be below the x-axis. Yeah, like this. So this is how your graph is going to look like, but it's just going to be below the x-axis, and it's still going to obtain a maximum point of -2. Okay, thank you.